The three leading factors related to site development that contribute to urban flooding and water pollution are 1. The development or alteration of floodplains and the subsequent loss of healthy floodplain functions. 2. Impervious surfaces and the resultant increases in stormwater runoff. 3. Combined sewer overflows. Floodplains are the lowlands and relatively flat areas adjoining inland and coastal waters that are subject to flooding. They are an extension of the water system. Their function is to convey high water volumes downstream or temporarily store water until flooding subsides. Fully functioning floodplains provide a variety of ecosystem services, including floodwater storage and peak flow moderation, resulting in the reduced severity of floods, filtration and removal of water pollutants, channel stability and erosion control, wildlife habitat, groundwater recharge, stream base flow, beauty, and recreational opportunities. Development and alteration of or encroachment on floodplains can disrupt or greatly reduce their ability to provide these valuable environmental and economic benefits. Floodplains are classified according to the likelihood of flooding in a given year. For example, the 100-year floodplain demarcates the elevation that has a 1% chance of being flooded each year. The term can be misleading and is commonly mistaken for a flood that will occur once every 100 years. In reality, the flooding can occur multiple times within a relatively short time period. Because flood events are not always consistent in their timing or severity, risks are often ignored or downplayed until flooding occurs, and it is too late to prevent poor development choices. The development and alteration of floodplains has resulted in an increase in flooding, danger to humanity, and environmental degradation. Flood damages in the United States average over $3 billion each year and account for about 39% of all deaths from natural disasters, more than any other type. Stormwater runoff is rain or snowmelt that flows off the site instead of soaking into the ground. Impervious surfaces are the primary cause of stormwater runoff in urban environments. Conventional roads, roofs, parking lots, and other impervious surfaces decrease the area of vegetated land available to infiltrate rainwater, which in turn increases the stormwater volume and runoff rate of the site. This disruption of the hydrologic cycle degrades the quality and reduces the quantity of water resources by limiting groundwater recharge and transporting pollutants from urban land to nearby waterways. Common stormwater pollutant sources include fertilizers, herbicides, and insecticides, animal waste, road salt, coal tar-based sealants used on paved roads, vehicle fluids, exhaust, brake linings, and tire and engine wear, sediment from improperly managed landscapes, roofing materials, and debris. Stormwater runoff from developed land is the leading cause of water pollution in urban areas. As the stormwater moves across urban surfaces, it increases in temperature and accumulates sediment, nutrients, pathogens, heavy metals, and other pollutants that adversely affect water quality and degrade downstream aquatic habitats. In addition, stormwater runoff increases the volume and rate of water entering sewer systems and stream channels, increasing the likelihood of flooding and the spread of pollutants. Conventional storm sewer systems typically utilize pipes, culverts, or channels to quickly and discreetly discharge stormwater runoff to receiving water bodies such as lakes, streams, and wetlands. The runoff is not treated and pollutes water bodies used for drinking and recreation, as well as wildlife habitat. In this table, we list the pollutants such as sediment, bacteria, and chloride. Next is the source, which shows bare soils, animal waste, pesticides, etc., and then lastly, the impact, such as harmful to the health of humans and wildlife. If you would like a copy of this chart, we have made a printable version that you may download from the Resources chapter of this course. Combined sewer systems, or CSS, collect stormwater and sewer and industrial waste into the same pipeline, and transport the wastewater to a treatment plant. During intense rain events, stormwater runoff can overwhelm the capacity of such systems. When this occurs, the CSS overflows and discharges excess wastewater into nearby streams, lakes, or other water bodies. Combined sewer systems serve an estimated 43 million Americans and are primarily located in older cities in the Northeast and the Great Lakes. There is also a small percentage along the West Coast. Combined systems are also common throughout Europe and make up a majority of the sewage systems in the UK. Replacing combined sewer systems with separate storm and sanitary sewers is an expensive and lengthy process. Many municipalities are successfully working with property owners to reduce stormwater runoff, and in doing so have avoided increases in infrastructure costs. Combined sewer overflows, or CSO, release stormwater pollutants and untreated human and industrial waste, toxic materials, and debris into nearby rivers, lakes, and other water bodies. The untreated wastewater is released in order to prevent backup into streets, homes, and businesses served by the combined sewer system. The overflows can greatly diminish water quality and are a health risk for humans and wildlife. CSOs also limit the aesthetic value and enjoyment of waterways. Common pollutants include bacteria such as fecal coliform and E. coli, viruses such as hepatitis and diphtheria, parasites such as Giardia and Cryptosporidium, metals such as lead, zinc, cadmium, and chromium, oil and grease, trash and litter, and nutrients such as nitrogen and phosphorus.